During the lab session or video session this week, we have learned about for loops, conditional statements, and function in Matlab. In this video, we will go through 3 examples on how doing so. This may be a good opportunity as additional exercise or just to have you a better understanding. You can download the problem from LearnUW under the Content tab and under the lab videos. You may choose to do the problem first by yourself and check the answer in the video, or we can go through the problem together. First problem is about the for loops. We are asked to calculate the sum of the even integers starting from 100 to 140. And then the key here is the even integers. So in Matlab, I have made a new script, a program to calculate summation of even integers. I made a comment there, and then CLC to clear the command windows and clear all to clear the variables. So I'm just gonna go ahead and type in new variables sum even equals 0 and entering the loop for j equals 100 in the increments of 2 until 140. So j is going to be 100, 102, 104, 106, etc. Sum even equals sum even plus j. Semicolon will suppress the output to the command window. And n, because we have to have an n for every 4 that we have. So let's think about this problem a little bit. That the first j will start from 100 and then sum even will be equal 0 because we have 0 here at the beginning plus 100. And we're still in the loop, so sum even again because the second j will be 102 equals 100 from the previous sum even plus 102, and then it keeps going until our j reach 140. We can run this now and then check our workspace that we have the result there. Alright, so should we look at the second for loops problem that we want to calculate the sum of the integers, the same problem, except for those integers that fall in the range of 120 to 130. One way to think about the problem is if j is less than 120 or j is bigger than 130, then we do the whole calculation. So this is somewhat like a conditional statement problem. So we modify our code, we put if as our condition inside the for loops. If j is less than 120 or j is bigger than 130, then we want to do this calculation. And if we have an if, we should have an and for that if. We can run it again. And then we see that our result makes sense because now it's going to be less than the previous result. Alright, so our second problem is fully about the logical statements, about the if problems, per se. We have this cantilever beam that is loaded at a distance of a, and a and b are not equal. So we have two conditions. If we are interested in looking at the displacements in this range, then we're going to be using this formula because x falls less than a. But if we're interested to know the displacement, for example, after the load to the end of the beam, then we should use this formula to calculate the displacement. So we already know that this is a if statement problem. We are given several constants, variables, and then we are asked to calculate the deflection at this x. In Matlab, I already opened the new script file again, and then I made comment clc clear all. I also already stored the variables that we know. the E, I, P, the length of the beam, and A, which is the cutoff. Again, I already stored an x vector which containing all the x, the distance from starting from the wall to the right of x that we're interested in looking at what is the displacement at that location. So we're gonna go ahead and start our for loops. For I, the index, again 1 to length of x. Length is a built-in function that will tell you the size of your vector. In this case, for example, x is gonna be total length is 6. So this is basically 6. Of if for say I mistakenly type in x to be negative, of course I do not want that. So I'm just gonna say if x turn out to be less than 0, display another built-in function, x needs to be positive and greater than 0. Now, oops, I missed an parenthesis. Now, we have a second conditional statements. If x falls in this range, so we can say that if x I x at whatever x, the first x, second x, less than a, then calculate this formula for y. We also need y to be indexed because we want to know the y that corresponds to the x that we specify. X cubed times 3 times a minus xi divided by 6 times e times I. Else, if it doesn't satisfy the first condition, if x is bigger than a, which is only one left condition, so we only need else, then calculate these y values. Times 3 times 3 times xi minus a divided by 6 times e times I. I'm gonna check if I'm typing it right. It looks good. And I have one n for the if, a second n for the for. So I'm gonna go ahead and run this program, and we can see our y values. We have 6, which corresponds to x that we have. So when we have x at 120, which is bigger than our a values, then we have this displacement. Alright, so let's see our third problem, which is function problems. We want to write a function that will convert the coordinate system, the xy coordinate system, to polar coordinate systems. So the input of this function is going to be x and y, and then the output is going to be r and theta. So if we go back to Matlab, I'm gonna be slower in this function session. So the first rule to write a function in Matlab is to actually write the word function in the very first line. And then after function, you need to specify your output. Well, your output is r and theta, but you have to write it in brackets. Okay? And after the equal sign is your function name. You can name your function anything, but just remember, don't put space in your function because it will give you an error. So in this case, I am going to name my function Cartesian to polar. Now, after your function name, you have to define your input. and I know my input is going to be x and y. So look at the syntax here. Function, your output in brackets, your function name, and your xy. And then save this. When you're saving a function, you have to save it as the same as the function name. So it seems, I mean, you cannot, for example, just type in polar while your function name is Cartesian to polar. So it has to correspond. So we hit save. Now, the second rule of function is that you have to define your output anywhere in the body of your program. Your output in this case is r and theta. So I'm gonna make a comment converting x and y to r. I am defining r right now. I am defining my output. R equals, the formula is that r equals square root of x squared plus y squared. Okay, so I already defined r and I am going to define theta, converting x and y to theta. And then the formula that theta equals arctangent of y divided by x. If you just type in like this, it will give the angle in radians. So I am going to multiply by 180 divided by pi to give me the angle in degree. So if you look at it, I already defined r and I already defined theta, and I'm defining them. In this case, I have an input of x and y. The input is over here, and then I end my function. I save it. Now, when you want to run your function, you don't run it from the run button. You don't also run it F5. You don't right click on it and hit run. No, but then you have to call your function from your command window, and in this case you have to call your function by the name. That's why we give it a name. So I'm going to clear all variables that are there, clear my command window, and I'm going to define my output. You don't have to have your output when you're calling your command as in the same, but then I can, for example, modify it to be r1 and theta1 equals your function name Cartesian to polar, and now this is your chance to define your x and y values, any one you want, like 3 and 5 for example. Then when I enter it, I got my r1 to be 5.8 and my theta1 to be 59 degrees, or you can also check out your workspace over here. So that's how you write your function program. Just remember the rules that you have to start the function with a function, the output equals the function name and then the input, and then you have to define whatever the output variables that you put somewhere in the body. Although when you call it, as in the third rule, you call it from the command window, you don't have to have the exact same output. Okay,